Everyone, myself Professor Khemchand Surana from the Department of Pharmaceutical Chemistry, Divine College of Pharmacy, Satana, Nashik. So in last session, we have seen about the introductory part of antibiotics. Today we will go through the beta-lactam antibiotics. Okay, so initially we will look into the introductory part of beta-lactam antibiotics, then we will discuss the penicillin, cephalosporin and other antibiotics. Okay, so basically the structure of beta-lactam given over here you can see. Okay, so beta-lactam uh, azetidione. Okay, so the structure basically given over here. Okay, so there is what four member ring, okay, with NH double bond O and alpha and beta carbon. So this is what structure. So the name lactam is given to the cyclic amide. Okay, so you can see the structure is what a four member ring. Okay, that is what cyclic structure, cyclic amide. Okay, and is analog to the name lactone, which is given to the cyclic ester. Okay, so whatever these lactam name given as per what whatever is analog, okay, lactone, which is what cyclic ester. Okay, so the lactam are most widely used group of antibiotics which is available. Okay, and antibiotics that contains the beta lactam. Okay, as we know the antibiotics which contain the beta lactam ring. Okay, beta lactam ring means what a four member cyclic amide ring. Okay, structure which constitutes the dominant class of agent currently employed for the chemotherapy of bacterial infection. Okay, so whatever the antibiotic which contain these beta lactam ring, okay, which is what four member cyclic amide. Okay, so this is what dominant class of agent. Okay, which is useful against the bacterial infection. Okay, penicillin subclass of beta lactam antibiotic. Okay, as we have to discuss the different subclasses of these beta lactam antibiotics, in that the penicillin subclass of beta lactam antibiotics is characterized by the presence of substituted 5 member thiazolidine ring fused to the beta lactam ring. Okay, so penicillin is what one of the class of these beta lactam antibiotic, in that whatever these beta lactam ring, okay, four member cyclic structure which is fused with the thiazolidine ring. Okay, so thiazolidine ring is what fused with these four member lactam ring, that is what the structure of penicillin. This fusion and the chirality of the beta-lactam ring results in the molecular roughly possessing a V shape. Okay, so whatever the fusion between these beta-lactam ring and the thiazolidine ring, okay, so this will leads toward the V shape structure. Okay, the molecule leads toward V shape. Then what is the historical background behind these beta lactam ring, okay, that we have to discuss. So basically again the structure of these beta lactam ring given over here. Okay, the first synthetic beta lactam was prepared by the Hermann Staudinger. Okay, so this is what the person he has discovered the these beta lactam ring in 1907 by reaction of the Gibbs base of aniline and benzaldehyde. Okay, so what he did basically Gibbs base, that is what aniline, okay, Gibbs base of aniline and benzaldehyde, he did the reaction between these, okay, with diphenyl ketone, okay, in cycloaddition reaction. Okay, so reaction type is what your cycloaddition reaction. So he has synthesized these beta lactam ring. Okay, then further the up to 1970 most of beta lactam research was concerned with what penicillin only and cephalosporin group. Okay, so these two basic subclasses of beta lactam antibiotics where means invention was going on, okay, up to these 1970. But since the wide variety of structures has been described, after that the many synthetic analogs has been synthesized and described. Then further we'll move to the classification of these beta lactam antibiotics. Okay, So classification of Betalactam antibiotics. So these are what basically inhibitors of cell wall synthesis. Okay, these Betalactam antibiotics are what inhibitors of cell wall synthesis. Their structure contain basically beta-lactam ring, as we are already seen, and the major subdivisions or subclasses are given over here. So first is what your penicillin. Okay, so penicillin, whose official name usually ends with what your cilin. Okay, CILI. Okay, cilin. So you can see the name of penicillin, the end is what your CILLIN. Okay, this is what penicillin. Then second class is what your cephalosporin. Okay, so cephalosporin were recognized by the inclusion of CEF or CEF. Okay, means SEF or SEPH in their official name. You can see the initial first three letters. Okay, CE, either F, okay, or CEPH. Okay, so both are what which recognizes the name of cephalosporin. Okay, next class is what your carbapinims. Okay, carbapinims. Examples of this carbapenem is what meropenem and imipenem. Okay, next is what your monobactam, fourth class. Example is what azithrionam. Okay, so this is what about monobactam. And last class is what your beta-lactam is inhibitor. Okay, so in that example is what clavulanic acid and sulbactam. So these are what different subclasses of your beta-lactam antibiotics that we have to look into the detail. Okay, so here is what the family tree of beta-lactam antibiotics. Okay, you can see, so according to year how they were invented. So initially the penicillin, okay, in 1940 the penicillin were what invented. You can see the structure of basic structure of penicillin over here given. Then further in 1976 clavulanic acid has been synthesized. Okay, further the carbapenems, okay, in 1976. Okay, these are what both also in 1976 no cardiacins. Okay, no cardiacins also developed. Okay, so these three basic beta lactams were developed during 1976, that it was clavulanic acid, carbapenems and no cardicins. Okay, then in 1981 monobactams were developed. Okay, and after that during the period of 1948, 1971 and 1985 the cephalosporin inventions were going on. In that the cephalosporin during the 1948, after that in 1971 there is what cefamycin, after that cefavacin in 1985. So this is what your family tree of beta-lactam antibiotics. Now here the four classes of your beta-lactam antibiotic with their structures. Okay, here you can see there is what structures given over here, different beta-lactam antibiotics. The lactam ring, that is what the main ring. You can see the beta-lactam structure over here. Okay, that is what if this beta-lactam ring is fused with thiazolidine ring. Okay, that is what penicillin. Okay, you can see the 5-member ring system which is attached to the beta-lactam ring in first structure. Okay, the penicillin, that is what the structure of penicillin, 5-member ring. So if the 6-member dihydrothiazine ring. Okay, so in you can see into the structure of cephalosporin. Okay, so 6-member dihydrothiazine ring. Okay, ring has been fused with this beta-lactam ring, that is what cephalosporin. Okay, next is what your carbapenems. Okay, so the beta-lactam ring is also joined to 5-member ring, although it is a carbocyclic. Okay, so here is what the structure of these particular carbapenem is what look like what your penicillin, but here is what there is what carbocyclic substitution is there. Means what on 5-member ring system there is what you can see the SR1 means sulfur will be there and COOH will be there. Okay, so that is what structure of carbapenems. Next is what your monobactam. Okay, fourth one Monobactam is what? Your monocyclic structure. Okay, so till this penicillin, cephalosporin and carbapenem, these are what? Fused ring system, but this monobactam is what? Your monocyclic beta-lactam structure. Okay, the side sulfo group is joined. Okay, you can see into the structure of monobactam there is what? Side sulfo SO3H, there is what? Sulfonyl group will be joined, okay, to the nitrogen ring. So this is what? Your monobactam structure. So all of these contains a 4-member beta-lactam ring. Okay, you can see the comparison. So the beta-lactam structure, that is what 4-member ring, is common in all ring system. Okay, this is what necessary for exhibiting their antibacterial activity. So these beta-lactam ring is what? Necessary for their exhibition or showing its antibacterial activity. So now next is what? Your here is what? The different ring system, okay, with numbering, okay, numbering of your beta-lactam antibiotics, okay, given over here. Okay, so here the first structure is what? Pinam ring system. Okay, Pinam ring system is available in case of what? Your penicillin. Okay, so that is what unsaturated ring system, Pinam. Okay, and Pinim is what? Your unsaturated ring system. So IUPAC name of your Pinam is what? 4-thia-1-aza bicyclo 30320 heptane 7-ONE. Okay, so as we know the nomenclature of bicyclic ring system or fused ring system, okay, we have to write in square bracket. Okay, so here is what? Cyclo 320 means what? At the left of the side, okay, there is what? 3 substitution will means 3 substitution will be there, means 2, 3 and 4 position, that's why 3. At the left right position there is what? 2, okay, means 7 and 6 position. Okay, and in center there is no bridge, that's why 0 will be there. Okay, so this is what? Your Pinam ring. Similarly Pinim, okay, so 4-thia-1-aza bicyclo 320 hept 2 in 7-on. Okay, that is what? IUPAC name. Further carbapenem, okay, so carbapenem structure will be here. The IUPAC name and numbering given over here. The IUPAC name is what? 1-aza bicyclo 320 hept 2 in 7-on. Okay, then Cfim, okay, Cfim in case of what? Your cephalosporin. Okay, so this is what? 5-thia at 5th position there is what? Sulfur 5-thia-1-aza bicyclo 420. Here is what? 4, because there is what? 4 substitution will be there. Okay, 1, 2, 3, 4 and 5. Okay, these position, that's why 4. Okay, then 2 at the right side there is what? 7 and 8 position, and in between there is no bridge, that's why 0. Oct 2 in. Okay, the 8-on at 8 position there is what? Ketone. So this is what about cephalosporin, that is Cfim. Then monobactam ring. Okay, so this is simple is what? Beta-lactam structure. Okay, that is what? Monobactam basic structure. So these are what? Different ring system involving in different beta-lactam rings. Now we'll move to the classification of beta-lactam antibiotics. Okay, so here is what? The classification of beta-lactam antibiotics. There are different classes. First is what? Penicillin. In that we have to see in detail. So the examples given over here. Further cephalosporin again divided into different generations. There is what? First, second, third, fourth and fifth generation. Okay, then carbapenems, okay, and monobactams. Okay, the examples given over here. So each category we have to look into the detail. Okay, now we'll move to the introductory part of the penicillin. So today we will start about the first important class of these beta-lactam antibiotic, that is what? Penicillin. Okay, so here basically penicillin is what? Most important antibiotic, was first extracted from the mold, that is what? Penicillium notatum. Okay, so that is what? The firstly extracted by what? The mold, that is what? Penicillium notatum. Subsequently also the mutant related molds, okay, means related strains or the related molds, okay, also from what? Penicillium chrysogenum. Okay, so first is what your Penicillium notatum, and its mutant species is what your Penicillium chrysogenum. Okay, these are two species was found to give the highest yield of penicillin. So these two species has given what highest yield of penicillin. The basic structure of penicillin basically consists of thiazolidine ring which is fused with the Betalactam ring. Okay, already we have seen the structure of penicillin, the 5-member ring, that is what thiazolidine ring system, which is fused with what your Betalactam ring, and which is essential for what your antibacterial activity. Okay, these two rings constitute the fundamental nucleus of penicillins. Okay, these are what two main nucleuses of your penicillin ring system, which is namely what 6 amino penicillinic acid, or in shortly we can called 6-APA. Okay, 6-APA. So these 6 amino penicillinic acid, this is what the fundamental nucleus of your penicillin. So variety of semi-synthetic penicillins are produced by altering the composition of the side chain which is attached to the 6-APA nucleus. Okay, 6 amino penicillinic acid nucleus. Okay, so we have to look into the different structures of this penicillin. Okay, so both 6-APA nucleus as well as the side chain. Okay, these are both essential for their antibacterial or the antibiotic activity. Okay. So now again the penicillin is what group of antibiotic that is commonly used to treat the different types of gram positive as well as gram negative bacterial infection. Means useful against is what your both gram positive and gram negative bacterial infection. So in their structure there is what Betalactam ring. Okay, located due to what its reason drugs are also called as a Betalactam antibiotics. So lactam ring will be there, that's why these drugs are also called as Betalactam antibiotics. So penicillin basically derived from the Penicillium mold, as already we have seen the Penicillium notatum and Penicillium chrysogenum. These are two molds. Okay, from that this penicillin has been derived. It destroys the bacteria by inhibiting the enzyme which is responsible for the formation of cell wall into the bacterial cells. So these how they were act basically, they will inhibit the bacterial cell wall. Okay. Now we'll move to the history of penicillin, how these penicillin has been discovered basically. So penicillin is what the world first antibiotic. Okay, the world's first antibiotic, that is what penicillin was discovered by the British scientist. Okay, so British scientist, name of the scientist is what Alexander Fleming. In 1928 he has discovered this penicillin by accidentally, so that's why we can call these drugs are serendipities also. Okay, so in 1928 Alexander Fleming discovered the compound which is produced by what fungus basically. Okay, the fungus is called as Penicillium notatum, as already we know, and which is what isolated compound which is called as a penicillin. Okay, so he has given the name of these isolated compound as a penicillin, and Fleming noted that the fungus growing on his bacterial plates had killed off the surrounding bacteria. Okay, so whatever he has observed, what he has observed basically, the particular penicillium has been developed on the plate and he is killing the surrounding bacteria. Okay, that he has observed during his invention. So further after that the Fleming, Foray and Chain, these three scientists, okay, received the Nobel Prize in 1945 for medicine for their work on the penicillin. Okay, so for whatever the work he did on penicillin, for that these Fleming, Foray and Chain, these three scientists, okay, you can see the pictures of these three scientists over here, they received the Nobel Prize. So as we know this penicillin is were discovered by accidentally. So how discover by accidentally, okay, that we have to see. So basically Fleming left the dish of Staphylococcus bacteria uncovered for few days. Okay, what happened basically, the Fleming leave whatever the plates of these Staphylococcus bacteria, okay, he leave that uncover onto its laboratory. Okay, and after few days he returned to the laboratory. Okay, so he found that the whatever the dish he left as it is uncovered, okay, in that there is what the formation of dots. Okay, there is what he seen particular dots has been developed, okay, with bacterial growth. Okay, apart from the one area where he patch of mold. Okay, he has developed the particular, you can see this you can see the pictorial diagram onto particular plate. Okay, at the particular end he has given the patch of these mold. Okay, that is what Penicillium notatum, that is what growing. Okay, and he is what whatever the Penicillium notatum, they were what killing the surrounding bacteria that he has observed. Okay, this is what the accidental discovery of penicillin, okay, by this Alexander. So newly discovered antibiotic substances, okay, penicillin was effective even when diluted up to the 800 times. Okay, so up to 800 times if we are diluting these particular penicillin, it is again effective, that he has given a particular statement during his invention. So here further you can see the pictorial diagram. So during the world wars, okay, this penicillin is what useful, and you can see this is what the news particular newspaper pictorial. Okay, that is what the penicillin is what new wonder from the mold. Okay, that is what useful against the bacterial infection. So we'll move to the chemistry of penicillin. Okay, so here is what the chemistry of penicillin given over here. Okay, so the penicillin as well as cephalosporin, as we know, these are what, and beta-lactam antibiotics, and characterized by three fundamental structural requirement. Okay, so you can see the structure of penicillin with numbering. Okay, so here is what the sulfur is given first name, then second with these two dimethyl ring, then third there is what free carboxylic group. Okay, then fourth to the nitrogen, fifth, sixth and seventh to the ketone. Okay, at sixth position there is what essential amide. Okay, and at 5 and 6 position these will show the cis stereochemistry. Okay, cis stereochemistry which is essential, and lactam ring you can see, and whole structure we can call bicyclic essential ring. Okay, so what is fundamental structural requirement into the structure of these penicillin is what? The first is what? Fused beta-lactam and thiazolidine ring. You can see the beta-lactam ring and thiazolidine ring has been fused, which will call the bicyclic system. Okay. Further, a free carboxyl acid group. You can see the free carboxylate group here. Okay, you can see, and further the one or more substituted amino side chain. So here is what amino side chain, okay, with R group. Okay, so at R position we can substitute anything, and there is what cis stereochemistry. So these are what different essential components of your penicillin. Okay, so now the chemistry of penicillin that we have to discuss. Okay, so basically penicillin nucleus consists of the thiazolidine ring, that is what ring A. You can see into the structure, the structure is what your ring A. Okay, so thiazolidine ring, here is what the sulfur containing COH group will be there. Okay, you can see in ring A there is what sulfur group will be there and COH group will be there. Okay, at both in ring A. Further, beta-lactam ring, that is what ring B. Okay, so this ring basically broken by the beta-lactamase enzyme. Okay, so by beta-lactamase enzyme this ring will be breaked, and the side chain is attached at the position 6. Okay, you can see the amide linkage with R substitutions. Okay, that is what side linkage. Okay, further the third one is what side chain which is attached to the amide linkage. Okay, that will broken by the amidase enzyme. Okay, so this will broken by what your amidase enzymes. Okay, so these are what three different functionalities or the structural requirement of your penicillin. So further, penicillin basically broken by the penicillinase enzyme. Penicillinase enzyme also called as beta-lactamase enzyme, or by the gastric acid. So by these different enzymes this penicillin has been broken down. Okay, so resultant product of these penicillin after breaking is what penicilloic acid. Okay, so penicilloic acid is what your resultant product after breaking of your penicillin with no antibacterial activity, means once this penicillin structure has been breaked, it has a no activity, but act as a antigenic determinant. Okay, act as what your antigenic determinant, this is what major determinant. Okay, so this is what your chemistry of penicillin. Now we'll move to the nomenclature of penicillin. Okay, so how we have to nomenclate these penicillin structure. So nomenclature of penicillin basically done into the different ways. Okay, different ways. So first is what your chemical abstract system. Okay, chemical abstract system, that is we can call case. Okay, case system of nomenclature of penicillin. So according to this system, basically penicillin are number starting from the sulfur. Okay, you can see into the structure. Okay, so according to this case system, the sulfur has to number first. Okay, then sulfur atom is assigned at the first position, and then the nitrogen atom is assigned. Means further this initially is what sulfur has been assigned and then nitrogen has been assigned. So first number goes to what sulfur, and after that the fourth number come to what your nitrogen ring system. That is what case system of nomenclature of penicillin. Okay, you can see the general structure of penicillin by this case. Okay, so first number is going to what your sulfur, second there is what 2 methyl group will be there, at third position there is what acidic group COOH will be there, fourth at fourth position there is what nitrogen, at fifth position there is what CH, at sixth position okay there is what CH with acyl side chain. Okay, means amide linkage will be there at sixth position, and at seventh position there is what ketonic group will be there. Okay, so this is what general structure of penicillin through this case system of nomenclature. The IUPAC name of this system is what your 6 acyl amino. At 6 position there is what acyl amino group will be there, at 2 position there is what 2,2-dimethyl will be there, and at 3 position there is what carboxylic acid will be there. So by this way we can nomenclate these, by this way we can nomenclate the penicillin. Okay, through this case system. Second is what your nomenclature of penicillin through USP system. Okay, United States Pharmacopoeia system, USP system. So this USP system basically also naming and nomenclate the penicillin, and which is what a reverse of case system, means chemical abstract system. So it is completely opposite to what case system. Okay, so according to this system basically nitrogen is given a number to the first position, and then sulfur assigned to the fourth position. Okay, means in this case the nitrogen has been assigned to the first position and sulfur has been assigned to the fourth position. Okay, so you can see the general structure of penicillin, this USP system. Okay, so at nitrogen there is what first position, at second position there is what COOH, second at third position there is what dimethyl group, at fourth position there is what sulfur group. So this is what the nomenclature of penicillin through USP system. Further, as a derivative of pinam, that is what third point in nomenclature that we have to look. Okay, so unsubstituted bicyclic system together with amide carbonyl groups has been named as a pinam ring system. Okay, so you can see the pinam structure that already we have discussed, that is what unsubstituted ring system. Okay, that is called as a pinam ring system. So according to this method basically, okay, according to what your USP system. Okay, according to USP system, this pinam ring system given as a name. Okay, so nitrogen given as a first position. Okay, and sulfur has been given at a fourth position. So 4-thiazine has a bicyclo 3,2,0 heptane 7-one. Okay, so this is what your derivative of pinam. Next is what your derivative of penicillinic acid. Okay, so in this method basically penicillins are named as a derivative of penicillinic acid. Okay, as we already discussed, the 6-APA 6 amino penicillinic acid is important and fundamental structure of this penicillin. Okay, which is essential for activity. Okay, So you can see the basic structure of 6 amino penicillinic acid over here. Okay, so numbering given as per your USP system. Okay, at 6 position there is what amino group will be there, that's why 6 amino penicillinic acid. Okay, now next is what your as a derivative of penicillins. So the different derivative of penicillin that we have to discuss. Okay, so as a derivative of penicillin onto the R group, okay, R group onto the acyl substitution will be there. So this system we can call tri-val system. Okay, tri-val system. So in this system basically 6 carbonyl amino penicillinic acid portion of the molecule is named as penicillin. Okay, so the 6 carboxyl amino penicillinic acid portion of the molecule is called as what? Penicillin, and different penicillin has been distinguished on the basis of R group. Okay, on the basis of R group to the amide linkage. Okay, on the acyl amino side chain, or we can call it amide linkage. Okay, so you can see into the structure there is what basic structure, that is what 6 amino penicillinic acid, that is 6 APA. It is it constitutes of what your thiazolidine ring and beta-lactam ring, and there is what acyl side chain, there is what R substitution will be there. So if R is equal to this CH2 benzene ring, okay, we can call benzyl penicillin, or we can also call it as penicillin G. Okay, and if we will substitute at R position, there is what phenoxy this phenoxymethyl ring. Okay, that is called as a phenoxymethyl penicillin or penicillin V. Okay, so this is what different derivatives of penicillin. So this system basically naming the penicillin is simple and serve as a good measure for the naming and comparing closely related to penicillin structures. However, basically this system is not well suited for compounds having a ring modified into the derivatives. Okay, so this is what about the different nomenclature system of your penicillins. Okay, now we'll move to the stereochemistry of penicillin. Okay, so penicillin molecule basically contain the 3 chiral atoms. Okay, so as already we have discussed the cis stereochemistry, they have shown at the position into what 5th and 6th position. Okay, so it has having a 3 chiral center at the position of C3, C5 and C6. Okay, at this position all natural as well as synthetic penicillin have the same absolute configuration. Okay, both natural as well as synthetic penicillins having same absolute configuration. Okay, at all these 3 chiral centers. Okay, so at 6th carbon atom, okay, at 6th position bearing a acyl amino group, as we know at 6th position there is what acyl amino group and has what L configuration. Okay, at 6th position there is what L configuration, whereas the carbon which is to the carboxyl group, okay, attached, okay, that is having a D configuration. Okay, at 6th position there is what acyl group, at this position this is what L configuration, and the carbon which is attached to the carboxyl group, okay, means at by USP system at position 2, okay, there is what COH group, at this position there is what D configuration. Okay, thus the acyl amino group and carboxy group are trans to each other. Okay, so both these whatever the amide group means acyl amino group and carboxyl group, these are showing the trans configuration at each other. Okay, with the formal alpha and later into the beta orientation related to the pinam ring. Okay, the absolute stereochemistry of this penicillin is what your 3s 5r 6r. Okay, that is what absolute configuration, and which is what essential as per your GPAD examination also. This stereochemistry whatever the red I have marked the red points. Okay, I have marked into the red color points. Okay, these all points are important as per your GPAD examination also. The atoms composing the 6 amino penicillinic acid are what biosynthetically derived, okay, from 2 amino acids. Okay, so how this penicillin has been derived from the biosynthesis process or biosynthetically. So by using these 2 amino acids L-cysteine and D-valine. So L-cysteine and D-valine, okay, these two amino acid, you can see the biosynthetic precursor of penicillin. You can see the reaction over here. So cysteine amino acid will there and valine amino acid will be there with these acidic group. So by biosynthesis, acidic group means what? 6 amino penicillinic acid. Okay, so by biosynthesis there is what? Synthesis of penicillin will be there. So you can see the biosynthesis process of your penicillin. So this is what about your stereochemistry of your penicillin. Okay, now here we have seen the introductory part of beta-lactam ring and your penicillin. Okay, so in next lecture we will look into the classification of your penicillin, okay, in detail. Till that, thank you and happy learning.